You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Hello and welcome to this episode of Maths Made Fun and Easy. My name is Ikenna Nwokolo, and today we'll be looking at the topic number bases. You know, the popular counting system that we have around the world is the base 10 counting system, where we have 10 digits from 0 to 9. And with these 10 digits, we are able to form any kind of number, no matter how big or small the number is. But that's not the only counting system that we have. We have other counting systems in other bases, and we also use other bases in various applications. For instance, in computing, we use the binary number base, where we have zeros and ones. All right. Now we need to know how to convert between these different bases. If you come to other things like currency, in Nigeria we use the naira, right? We need to know, how do you convert from naira to dollars? How do you convert from dollars to euro, and so on and so forth? We also need to know how to do some basic operations in different bases. In base 10, we know how to add, subtract, multiply, divide, and so on. We need to know how to do that in other bases as well. And finally, we need to know what number base was used in a particular operation. So these are the three items that we'll be looking at in this particular topic. The first is how to do various operations in other bases. Okay. Secondly, we'll be looking at how to convert between bases. And thirdly, how to determine an unknown base. All right, so I hope you find this topic very interesting as we move on to take some practice questions with these three subtopics in mind.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
So now to the first question in this video. This is a practice exercise, so you practice along with me. And that means you need to have your pen and your paper ready and attempt the question before watching my explanation. The first question, add 1101 base 2, 10111 base 2, and 111 base 2. So we want to see how to add in other bases. So first of all, I'll write the first number here, then plus, you know how you do in base 10, you start with the unit digit. So we're going to write from the right-hand side this way, 1101. Okay? This arrangement is very important because if you misarrange it, then you would not get the answer. Then this will start with the unit place as well, 111, and then this is base 2, this is base 2. All right, time to add. 1 plus 1 plus 1, that is 3, but mind you, we are dealing with base 2, so we can't write 3 here. Instead, we'll say 3 divided by 2, this will give us 1 remainder 1, right? So we write the remainder just as we do in base 10, and then this, we take it to the next place value. So we bring 1 here. 1 plus 1 plus 1 again is 3. So instead of writing 3, we write the remainder and then take 1 to the next place value. 1 plus 1 plus 1 plus 1, that is 4. So instead of writing 4, we say 4 divided by 2. This is going to give us 2, remainder 0. We write the remainder, which is 0, and then take 2 to the next place value. 2 plus 1 is 3. We are not going to write 3. Instead, we write 1 and take 1 to the next place value. And so we have 1 plus 1 is 2. Again, we won't write 2. Instead, we write the remainder, which is 0, and then take 1 to the next place value. Now, since there's nothing here, then we bring down our answer as 101011 base 2. I hope you got this.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Now to the next question. I hope you are attempting the question before watching my explanation. Subtract 16418 base 9 from 18630 base 9. So we want to see how we subtract in other bases. 18630 base 9. I'll take this away from it, which of course I'll start writing from the units place. 81461. This is in base 9. Good. So we are subtracting. 0 minus 8. You can't do that. So you have to take from the next place value. You are taking 1 from 3. So we'll be left with 2 here. And then I will move 1 here. Now, you know, in base 10, when you take 1, you're actually taking 10. But this is in base 9, so you're taking 9 instead of 10. So this is going to be 9. 9 minus 8 is 1. 2 minus 1 is 1. 6 minus 4 is 2. 8 minus 6 is 2. And 1 minus 1 is 0. So we are left with 2211 base 9. Interesting and easy.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Now to question number 3. Simplify 213 base 4 times 23 base 4. All right, attempt the question before watching my explanation. Just like we do in base 10, we say 3 times 3, that will give us 9. But we can't write 9 here because this is base 4, right? The digits that base 4 can accommodate is 0 to 3. It can't accommodate anything above 3. So 3 times 3 is 9. Instead of writing 9, we say 9 divided by 4. This is going to give us 2 remainder 1. We write the remainder and take 2 to the next place value. 3 times 1 is 3 plus 2 is 5. Instead of writing 5, we say 5 divided by 4. This is going to give us 1 remainder 1. We write the remainder and take 1 to the next place value. 3 times 2 is 6 plus 1 is 7. Instead of writing 7, we say 7 divided by 4. This is going to give us 1 remainder 3. So we write 3, the remainder, and then since there's nothing, no other digits after this, we bring down the 1 here. Then we go 2 times 3 is 6. Instead of writing 6, we say 6 divided by 4. This is going to give us 1 remainder 2. We write the remainder, which is 2, and then take 1 to the next place value. So I put in 1 here. 2 times 1 is 2 plus 1 is 3. So we write 3 here. 2 times 2 is 4. But we'll not write 4. Instead, we'll say 4 divided by 4. This is giving us 1 remainder 0. We write the remainder of 0 and take 1 to the next place value. And just like we do in base 10, we would add 1, 3, 6. Instead of writing 6, we're going to write the remainder of 2 and take 1 to the next place value. 1 plus 1 is 2. We write 2 down here and we write 1. So we have our answer as 12231 base 4. I hope you got this. Now you can see how we do certain operations in other bases. We've looked at addition, subtraction, multiplication. See you in the next question.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Still on operations of numbers in other bases. We have question 4, 202 base 3 squared minus 112 base 3 squared. Now this is an objective question, and you know, they don't give a lot of time in the exam for objective questions. So you have to find a way to get to the answer pretty fast. I can use difference of 2 squares. You know, when you have a square and you have subtraction in between, you can factorize using difference of 2 squares. For instance, if I have a squared minus b squared, I can factor this as the first one, A, plus the second one, B, brackets the first one minus the second one. So this and this, they are the same thing, okay? So with this will be a faster way to solve this rather than square this, and then subtract. It will be much longer. All right, so let's do the same thing here. So to factorize this, I would write 202, the first one, plus the second one, brackets the first one minus the second one. Okay? So let's add this now. 202,112. This is in base 3. Then multiplied by 202,112. We are subtracting here. Okay? So adding this, 2 plus 2 is 4, but I can't write 4. Instead, I'll write the remainder, which is 1, and take 1 to the next place value. 1 plus 1 is 2, and then 2 plus 1 is 3. I can't write 3. Instead, I'll write the remainder, which is 0, and take 1 to the next place value. So we have the sum of 202 and 112 base 3 as 1021 base 3. Now let's get the difference. 2 minus 2 is going to be 0. 0 minus 1 cannot go, so I'll borrow 1 from here. This is in base 3, so what I'm actually borrowing is 3. 3 minus 1 is 2, and then 1 minus 1 is 0, right? So we have 20 base 3. Now we multiply this by this. So multiply, because of space, let me just multiply from here. We're multiplying this by this. All right, so 0 multiplied by anything is 0, right? Then 2 multiplied by 1 is 2. 2 times 2 is 4. But instead of writing 4, since we are dealing in base 3, I'll write the remainder 1 and then take 1 to the next place value. 2 times 0 is 0 plus 1 is 1. 2 times 1 is 2. So we add, we have 0, we have 2, we have 1, we have 1, we have 2. So our answer is 21120 base 3. All right? It took some time, but if we first square this, and then did subtraction, it will take more time.
You're watching Maths Made Fun and Easy with Ikenna, Maths teacher.
Now we move on to conversion between bases. First, we'll look at how to convert from base 10 to other bases. Convert 35 base 10 to a number in base 2. Now, if you want to convert from base 10 to other bases, all you need to do is to keep dividing that number by the base you want to convert to. So we divide 2 into 35. 2 into 3 is 1, remainder 1, into 15 is 7, remainder 1. 2 into 17, this will give us 8, remainder 1. 2 into 8 is 4, remainder 0. 2 into 4 is 2, remainder 0. 2 into 2 is 1, remainder 0. And then 2 into 1 is 0, remainder 1. So you have to divide until you get to 0, right? And then you read up the remainder from bottom up. So 35 base 10 to base 2 is equal to 1, 0, 0, 0, 1, 1 base 2. Easy, right?
You're watching Maths Made Fun and Easy with Ikenna, Maths teacher.
Next, let's see how we convert from other bases to base 10. The first thing you want to do when converting from other bases to base 10 is to label the digits. So we label from 0 upwards this way. So 0, 1, 2, 3, 4, 5. So this 101101 base 2 will be equal to 1 times 2 raised to power 0. So the number or the digits times the base raised to power the label. Okay? So 1 times 2 raised to power 0 plus the digit times the base raised to power the label. 0 times 2 raised to power 1. And you know, anything multiplied by 0 is still 0, so I don't need to write this. So anywhere we have 0, I'll skip it. Any digit that is 0 will get 0, so I need to skip that, right? 1 times 2 raised to power 2 plus 1 times 2 raised to power 3 plus this will give us 0. 0 times 2 raised to power 4 is still 0, so this is out. 1 times 2 raised to power 5. All right, so what do we have here? 2 raised to power 0, anything raised to power 0 is 1. 1 times 1 is 1, plus 2 raised to power 2 is 4, times 1 is 4, plus 2 raised to power 3 is 8, times 1 is 8, plus 2 raised to power 5 is 32, times 1 is 32. So this is going to give us 44, that is 45 base 10. So you can see how easy it is to convert from other bases to base 10. The first thing is to label the digits, and then you expand this way by saying the digit multiplied by the base raised to power the label. Like that, you add them up, and whatever you get is your value in base 10.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Now let's see how we convert between other bases other than base 10. It's just like for currencies, we see how we convert between other currencies other than Naira. All right, change 432 base 5 to a number in base 3. We normally employ two steps. The first step is to convert from the base, the initial base, to base 10, and then from base 10 to the base that you want to arrive at. So the first step, step 1, would convert this 432 base 5 to base 10. Now, to convert this to base 10, you have to label the digits first, right? So we have 0, 1, 2. Then we would have, we say 2 times 5 raised to power 0. The digits times the base raised to power the label, plus the digits times the base raised to power the label, plus the digits times the base raised to power the label. All right, so this gives us 5 raised to power 0 is 1 times 2 is 2, plus 5 raised to power 1 is 5 times 3 is 15. 5 raised to power 2 is 25 times 4 is 100. So this gives us 115 plus 2, which is 117 base 10. The next step is to change this from base 10 to base 3. And you know how we do it? We keep dividing 117. We keep dividing 117 by 3. So 3 into 11. This will give us 3, remainder 2. Into 27 is 9. No remainder. So write remainder 0. 3 into 39. This will be 13. No remainder. 3 into 13. This will be 4. Remainder 1. 3 into 4 is 1. Remainder 1. 3 into 1 is 0, remainder 1. So when we get to 1, we stop, and then we read up the remainder from bottom up. So we have 432 base 5 in base 3 as 1, 1, 1, 0, 0 base 3. I hope you're finding this video interesting. Now to the next question.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Do well to attempt the question before watching my explanation. Calculate 243 base 6 minus 243 base 5, expressing your answer in base 10. So what we are going to do is to convert first before subtracting. So 243 base 6 minus 243 base 5. So to express this in base 10, I'll label the digits 0, 1, 2, 0, 1, 2. And then we say 3 times 6 raised to the power 0 plus 4 times 6 raised to the power 1 plus 2 times 6 raised to the power 2. Then minus what we have here, right? 3 times 5 raised to the power 0 plus 4 times 5 raised to the power 1, then plus 2 times 5 raised to the power 2. So what would this give us? This is 1 times 3, which is 3, plus 6 times 4 is 24, plus 36 times 2 is 72. Then minus 1 times 3 is 3, plus 5 times 4 is 20, plus 25 times 2 is 50. Remember, we are now in base 10, right? 3 plus 24, that will give us 27. 27 plus 79. Sorry, 27 plus 72, that will give us 99, right? 99, already we are in base 10, minus 23 plus 50, that is 73. Okay, so we are subtracting now. 9 minus 3 is 6, 9 minus 7 is 2. So we have 26 base 10 as our answer.
You're watching Maths Made Fun and Easy with Ikenna, Maths Teacher.
Now we move on to questions on determining the unknown base. Question 9. If 104 base x is equal to 68, find the value of x. Now, when a base is not indicated, you take it to be base 10, because in our normal counting system, we don't always write base 10. If it's not written, then it is in base 10. So, which base is x? That's what this question is asking. So what we are going to do is to expand 104 base x, which would make it to be in base 10 as well, right? And then equate it to 68. You know, when you are changing from other bases to base 10, we label the digits first, right? So 0, 1, 2. So we are changing now the digits multiplied by the base raised to power the label. So that will give us 4x raised to power 0 plus 0, the digits, times the base raised to power the label, right? Now, but you know, anything multiplied by 0 is still 0, so we can skip that. Then we say 1 times x raised to power 2. And, you know, anything multiplied by 1 is still that thing, so we can write this as x squared. So this is equal to 68. Now, x squared will be equal to what? This here, x raised to power 0 is 1. Anything raised to power 0 is 1. So this is 1 times 4, which is 4. So 4 plus x squared is equal to 68. So that x squared will be equal to 68 minus 4. So x squared is equal to 64. Now we can express 64 as a square as well, so that x squared will be equal to 8 squared, right? And you know, in the laws of indices, if we have the powers the same, then the base have to be the same. So x is equal to 8. So the value of x here is equal to 8. So this is 104 base 8, that is equal to 68 base 10.
You're watching Maths Made Fun and Easy with Ikenna, Maths teacher.
We are making progress. We are now looking at how to determine an unknown base. Like in this case, what base is this 2, 3? This y, what base is it? Now, in the last question, I showed you that to determine an unknown base, you try to convert that unknown base to base 10. And you arrive at an equation that helps you find the unknown base. So that's the same thing we're going to do here. We'll convert all the bases to base 10, both the known and the unknown, okay? So 2, 3 base y equals 1, 1, 1, 1 base 2. So converting this to base 10, I will label 3 times y raised to power the label. That will give us 3y raised to power 0 plus 2y raised to power 1. This is equal to our label 0, 1, 2, 3. This is equal to 1 times 2 raised to power 0 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 2 plus 1 times 2 raised to power 3. So both numbers are now in base 10. So this gives us 3 raised to power y raised to power 0 is 1 times 3 is 3. Y raised to power 1 is y times 2 is 2y. This gives us 1 times 1 is 1 plus 2 times 1 is 2 plus 4 times 1 is 4 plus 8 times 1 is 8. So 3 plus 2y is equal to 3, 7, 15. So 2y will be equal to 15 minus 3. So 2y is equal to 15 minus 3 is 12. To get y, I'll divide both sides by 2 so that our y is equal to 6. So y is equal to 6. So it is 2, 3 base 6 that is equal to 1, 1, 1, 1 base 2. I hope you got this. And I hope you are attempting the questions before watching my explanation. The purpose of this video is for you to practice, and you don't practice by just watching videos. You practice with your pen and your paper.
You're watching Maths Made Fun and Easy with Ikenna, Maths teacher.
I'm sure you're enjoying this video, and I also hope that you are attempting the questions before watching my explanation. So attempt the next question. If 101 base 2 plus 12 base y is equal to 2, 3 base 5, find the value of y. So we are still determining the unknown base. And the step that we take is to, first of all, convert all the numbers to base 10, and then we'll see what equation that we get. So 101 base 2, we'll convert that to base 10, plus 12 base y is equal to 2, 3 base 5. So to convert to base 10, we'll label the digits first, and we'll say 1 times 2 raised to power 0. Because of space, 2 raised to power 0 is 1, times 1 is still 1, right? Plus 0 times 2 raised to power 1. Anything multiplied by 0 is still 0, so we'll cancel out. 1 times 2 raised to power 2. 2 raised to power 2 is 4, times 1 is 4. So 101 base 2 to base 10 is 5 base 10, right? Plus 1, let's label the digits, 2 times y raised to power 0. Y raised to power 0 is 1, times 2 is 2. Then 1 times y raised to power 1, or y raised to power 1 is y, times 1 is still y. So this is equal to, we label the digits, 3 times 5 raised to power 0. 5 raised to power 0 is 1, times 3 is 3, plus 2 times 5 raised to power 1. 5 raised to power 1 is 5, times 2 is 10. So we have 5 plus 2 is 7. 7 plus y is equal to 13. So y will be equal to what? 13 minus 7. So y is equal to 6. Pretty easy.
You're watching Maths Made Fun and Easy with Ikenna, Maths teacher.
If you enjoyed this video, why not subscribe to this YouTube channel so you have more interesting maths videos like this that will help you excel in mathematics.
You're watching Maths Made Fun and Easy with Ikenna Maths Teacher.